All right, number 2 in rational expressions, we have P divided by 9 minus 2P minus 9 divided by 16, and then that is equal to P minus 9 divided by 12. We want to multiply by the common denominator, and so these are some larger numbers, may not be as easy to see common denominator, so I'm going to break each of these numbers down to prime factorization and find the common denominator. Another way is a dividing prime method. If you've not seen that, I'll show you that now. I will put all of these factors in what I call this little box, and I want to divide out anything that they have in common. Well, 9 is divisible by 3, but 16 and 12 are not. I'm sorry, 16 is not, but 12 is. If you can divide any of these numbers or any two of them, that's what you want to do. So since I can divide a 3 from two of them, I will do so. Now this only works with the least common multiple, so I'm trying to find the least common multiple between these three numbers. So I'm going to divide out a 3. 9 divided by 3 is 3. 16 is not divisible by 3, so I'm just going to bring it straight down. And then 12 divided by 3 is going to leave us with 4. Okay, so now I'm going to keep going, and I'm going to see if I can divide anything between all three or any two. And I can divide 16 and 4. Both of those are divisible by 4. So 3 is not divisible by 4, so I'll just bring it straight down. 16 divided by 4 is 4, and 4 divided by 4 is 1. Okay, so at this point, all of these numbers are relatively prime to each other, meaning they have nothing in common with each other. Once you complete this process, we will just multiply all of the outer numbers. It kind of makes like a little L shape, as you see. L for least common multiple. And so if I multiply 3 times 12, I'm sorry, 3 times 4, I'm saying the multiple. 3 times 4 is 12, 3 times 4 is 12. 12 times 12 is 24, times 1, sorry, not 24, 144. I just completely added. So 144 looks to be our least common multiple. This is the magic number that we want to multiply each of these expressions by, that's going to get rid of the fractions and give us a nicer problem to solve. So I'm going to multiply everything by 144. So basically what I'm doing is 144. It's going to really, I'm dividing. I'm trying to get rid of the fraction. And I'm putting the P over here. And I'm doing the same thing over here. 144 will get divided by 16. And then that expression 2P minus 9 is going to get multiplied. And then over here 144. And then P minus 9 is going to be divided by 12. Okay, 144 divided by 9 is going to give us 16p. 144 divided by 16 is going to give us 9, and that 9 is going to get distributed times the 2p minus 9. 144 divided by 12 is going to be 12, and then we're going to distribute that times p minus 9. So this is the simplified version. We don't have any more fractions, just whole numbers, so it's a lot nicer. So we have 16p. We're going to subtract 18p. That's the 9 times 2. And then 9 times 9 is 81. It's a negative 9. Negative times a negative is going to give us a positive 81. So be careful with the signs. And then 12p. And 12 times 9 will give us a 108, negative 108. We're going to combine like terms. We have two terms with p. 16 minus 18 will give us a negative 2p plus the 81. That equals 12p minus 108. Okay, so we'll combine like terms. I'm going to add the 2p. All right, so I'm going to combine the p, the two expressions with variables. I'm also going to move the numbers to the same side. So the p's will be on this side, so I'm going to move the 108 over here. So I'm going to add 108 to both sides. All right, so the 108 positive and negative cancel. The 2p positive and negative cancel. So this is what I end up with. 189. And then over here, that is equal to 14p. And so now we will divide by 14. And that will leave us with p, running out of room, p equals, now I believe both of these numbers are divisible by 7. You can use a calculator, but let's see, 189. 7 will go in there twice. And then 7 times 7 is 49. So divide by 7, that's going to leave us with 27. And 14 divided by 7 is 2. So 27 over 2.